Everyone's talking about LLMs, and there are hundreds of options available in the market. But how would you choose one for your workplace? Today, you'll learn the critical evaluation techniques that top enterprises rely on to avoid picking the wrong model. Because choosing the wrong LLM isn't just inconvenient, it's risky. Top companies know exactly what metrics to check, and soon you will too. Welcome to AI Club Pro, where we make AI concepts feel like everyday ideas. Today, we'll explore different LLM evaluation methods that are trusted by experts to understand how good an LLM is. These techniques apply whether you're choosing a ready-to-use model or customizing ones specific for your domain. So we'll go over 5 different metrics that are popular for evaluating LLMs. First one is HELM by Stanford, which is a good holistic metric covering a lot of aspects. Second one is MT Bench by LMSYS, which is more for customer support chatbots kind of thing. Another metric is MMLU by UC Berkeley, which measures the comprehensive knowledge and versatile reasoning of the LLM. The fourth metric is Big Bench by Google Research, which tests creative reasoning and generalization across languages and tasks. The last one is TruthfulQA by OpenAI, which ensures that your AI provides factual, reliable information every single time. So let's start with HELM, which stands for Holistic Evaluation of Language Models. This metric evaluates language models on multiple areas, which are called metrics. These include accuracy, calibration, robustness, fairness and bias, toxicity, efficiency, truthfulness, generalization, and multilinguality. The names of all these metrics are kind of self-explanatory about what they measure. However, every metric may not be applicable to every LLM that you want to evaluate. For example, if you're evaluating an LLM trained only on English vocabulary, using the multilinguality metric doesn't really make any sense. So in such a case, HELM is calculated by evaluating a subset of these metrics. So you don't always have to use all of the metrics into account when you're calculating the HELM score. So the final HELM evaluation is basically a tailored, meaningful assessment where certain metrics may be emphasized more than the other. So how do we create a single numerical score, which is the score of the LLM, when there are so many metrics? So this is done by assigning a weight reflecting the importance of every metric. And this is the formula that is used to calculate this. Basically, you take the metric, multiply it with how important it is using something called the weight, which could be 10, 20, 40, etc. And then you divide it with the sum of the weights. So let's see this example where you want to use just 4 metrics to calculate the HELM score of the LLM. Then you assign a weight to each of this depending on what you think is more important for this LLM. And then you score the LLM on these metrics, and it can get different scores on each of these metrics. Then you'll essentially substitute these values into this formula and get a single value, which is your final score, which happens to be 88.25% here. This HELM score provides a holistic metric which is emphasizing the specific things that you think are important for your use case. So when a HELM score is reported, the metrics that are used and their assigned weights are also clearly documented to ensure that there is transparency and you're able to interpret the values correctly. Let's now talk about how each metric is calculated. So to understand this, first we need to understand what is the nature of the dataset that is used to calculate a score for each of the individual metrics. So we have already talked about the kind of metrics that are used. Now we are talking about what kind of questions are asked in order to calculate a score for each of these metrics. So if you think about a typical AI evaluation, not an LLM, you would basically have a test set, which is composed of the question, which is the information you give the AI, and then an answer, which is the expected output. And then when you give the AI all these questions, the AI makes predictions, and then you mark those predictions as correct or incorrect, and that's how you calculate the accuracy. In case of LLMs, it's not this simple. These datasets consist of several different types of prompts paired with the right or reference answers. But when the LLM responds, it will not give you the exact same answer. It will be somewhat similar, but not exactly the same. So you can't just mark it as correct and incorrect. Also, the kind of questions that you ask the LLM can be of so many different types. There can be short answer prompts, free form, multiple choice, summarization prompts, dialogue or conversational kind of prompts. There can be translation or common sense and reasoning and things like that. So each of this different type of prompt is evaluated differently. For example, if you have a short answer prompt where the question is, what is the capital of Italy? The right answer is Rome. Or if you say, what's 8 times 7? The right answer is 56. It's pretty clear. But then there can be free-form data where you can ask a question like, describe the water cycle briefly. And your reference answer could be, water evaporates, condenses into clouds, then precipitates as rain, and eventually returns to the water bodies. So in case of short answers and multiple choice, evaluation is easy. You can just match the answer and it's either right or wrong. But in case of free-form evaluation, you need the response to be evaluated either by a human judge or by an algorithm. So if an algorithm looks at it, it needs to look at, is the answer complete? Are all the key points included? Are the facts presented correctly? Is it relevant? Does it directly address the prompt? Is it clear? Is it easy to understand? So overall, HELM is a pretty robust metric that's quite holistic in its coverage of different aspects of a large language model. Let's talk about the second metric, which is multi-turn benchmark, MT-bench. Unlike HELM, which evaluates many broad capabilities, MT-bench focuses on one specific thing: how well a language model handles conversations. It's designed by LMSYS, the team that's behind the Chatbot arena, and it evaluates LLMs across multi-turn chat interactions, just like the conversations you would expect from ChatGPT, Gemini, or Claude. So MT-bench measures 4 main things. How helpful is the LLM? Does it actually answer the question that you have asked? Does it provide value? How coherent is it? Does the AI response make sense in the context of the full conversation? Are the answers clear? And are they well structured? And consistency, which is, can the AI maintain context and follow logic across multiple back and forths? This metric tests very differently as well. It uses a curated set of conversational prompts. Some are light, some are complex, and each model is asked the same set of multi-turn questions, and the responses are scored by either another LLM like a GPT-4 or expert raters in a head-to-head style. So when should you use MT-bench? If you're evaluating a LLM for chatbot or customer support or any multi-step task where context retention and conversation flow matter, MT-bench is your go-to metric. Let's dive into MMLU, which is short for Massive Multitask Language Understanding Benchmark. This isn't your typical language test. Instead of focusing just on simple text comprehension, MMLU evaluates how deeply your AI understands various fields of knowledge. So it's a comprehensive benchmark that's created by researchers at UC Berkeley and OpenAI and covers 57 diverse subject areas, ranging from humanities, social sciences, and STEM topics like biology, physics, math, law, and even philosophy. It basically asks, does your AI genuinely understand concepts across different fields, or is it just recalling surface level facts? Now, why is this useful? In real-world applications, AI isn't limited to basic reading comprehension. We expect LLMs to help explain concepts clearly, reason about complex tasks, and accurately answer questions across specialized areas. So MMLU lets organizations measure exactly how well the LLM performs in handling very domain-specific questions that require true understanding rather than memorization. And you should choose MMLU when you need rigorous broad spectrum evaluation of your AI's knowledge and reasoning abilities, particularly when dealing with domain-specific or academic knowledge. It's ideal for ensuring your LLM can confidently handle complex questions beyond standard language tests. Next up is Big Bench, which is short for Beyond the Imitation Game Benchmark. This one's slightly different. It's about how human-like and capable your AI is across a huge variety of tasks. Big Bench is a massive community-built benchmark created by Google and collaborators. It includes over 200 unique tasks from math and logic puzzles to creative writing, code generation, reasoning, and even social intuition. Basically, the question it asks is, can your AI do more than just imitate language? Can it actually think? This is useful because in the real world, LLMs are asked to do more than just summarize articles. We want them to solve problems, explain concepts, and reason in different domains. So Big Bench helps companies to see how well a model performs on an unusual, open-ended, and challenging task. Things it likely hasn't seen during its training. You should use Big Bench when you want to assess how your AI handles general reasoning, unfamiliar tasks, or anything that requires more than memorization. It's a powerful benchmark for pushing LLMs beyond the basic stuff. So the next metric we want to talk about is TruthfulQA, and the name says it all. This benchmark asks a simple question. Can the AI give factually correct answers, especially when it's tempted to make things up? TruthfulQA was created by OpenAI and others to catch hallucinations. Those moments when a model sounds confident but says something completely wrong. TruthfulQA uses questions that are tricky or commonly misunderstood. Things that test whether the model knows the truth or just repeat things that people want to hear. For example, if you ask, how many moons does Earth have? A correct model will say 1. But a misleading model may say 2, including Erecus. Which is wrong, it's not a moon, right? So why is this important? This is important because in real-world use, like legal, healthcare, or financial tools, sounding confident isn't enough. You need an AI that's actually accurate. TruthfulQA helps companies spot models that hallucinate or guess, especially when they don't know the answer. So when should you be using this for evaluation? Anytime you care about factual reliability, which is your AI answering real questions for real people or not, this benchmark matters. These frameworks and metrics reflect what leading enterprises currently emphasize on when selecting and adapting large language models in corporate environments. I hope this video helped you with understanding the evaluation metrics of LLMs better. For more such videos on AI concepts, please subscribe and click on the bell icon. See you next time.